Hi, I'm Simon Hope and welcome to this KS YouTube channel, and I'm going to talk about my new vacuum system. I've actually been making them for maybe 10 years plus, but the old system you had to make each individual part for each lathe, and I'm really excited about the new design of this, which uses a rotary coupling, M33 on that end, and the chucks can just simply screw on, so you don't have to rely on the tube, which was the old-fashioned way of going through the headstock and matching up to different lathes. So what's really good about this system, yes, it's the rotary part because that's the magic bit that makes it happen. This bit spins, that bit stays stationary and allows the air to come through, and it has to be 100% air sealed. The products that we've actually made it from is stainless steel for the main body. The reason for that is quite often the vacuum will actually suck out moisture, and that will sit inside the system and maybe rust and corrode other systems, but obviously stainless steel, that's not going to happen. You might also notice that we've used a sort of plastic type material on here, and we've done that for a reason because yes, we could have made it out of aluminium or something like that, but it actually generates a lot of heat. There's some friction in there to make it airtight. But this product, the sort of engineering plastic called acetal, dissipates the heat and reduces the heat build-up, and it just works. It works really well. So this part simply screws on, M33 3.5. Let's just get that mounted on there. The other great feature about this system is that I thought about a sort of safety bar. If we didn't have a safety bar and we just had the tube, there could be an instance where the tube would actually get wrapped up. So I've thought about that and added this safety bar. So this bar comes as standard length, and it will suit any lathe up to sort of 24-inch swing, possibly even longer than that. But if you've got a shorter lathe, maybe you'll just have to shorten that by just cutting the bar. It wants to drop down about ½ inch beneath the top of the bed, just to allow then this cone just to sit in and lock, and that prevents any movement or slippage of that coupling part in the centre. So all the tube simply pushes into these quick release couplings. You need to sort of push it in about 10 mil until you feel it seat, and then for sort of disassembly, you simply pull back that flange and it will just pop out. Now you'll notice that I have two different size tubes. This is 8mm and this one here is 10mm, which goes down to the vacuum pump. The reason I've done two different sizes is that you can't get the tubes mixed up. You have to have it this way round so that the filter protects the pump. So that's why we have two different sizes. So this is the gauge and the filter. It also has a bleed system which allows air into the system, so you can adjust how much suck you have basically. If you do something really thin and you have it on full vacuum, full suck, it can actually implode the wood, so in that instance you can adjust how much air you want coming in. On this system we actually have the KS bracket, but we also do like a wall-mounted bracket, so you could just mount this somewhere in your eyesight so that you could see the gauge, because that will tell you the indication of if you're losing vacuum, and if it goes beneath sort of -20, as we say, as a safety zone, then you can keep an eye on that for safety. So the tube comes in, that's your bleed valve, which you'll see in operation when I show you how it all works, and this is a filter going down to the vacuum pump. So this is a moisture trap, moisture and dust. I've had one in the workshop for 10 years plus and I haven't had to clean it out yet. It may have some dust in the bottom, but if it does get a lot of moisture, you can simply pull the little lever here at the bottom, or you can unscrew the blue cap, use an airline just to clean it out, but you shouldn't have to do that very often at all. So the vacuum pump that I use is an oil-free vacuum pump. It's like a rocking piston pump, and it's about 4.5 CFM, which is a reasonably sort of powerful pump. I use an automatic plug. You can buy those on Amazon. It doesn't come with a kit, unfortunately. They're not very expensive, and I can simply go on and off when I'm using it just from this remote, so that's really handy to use. So there's two chuck sizes available, 4.5 inch and 6 inch. So these just simply screw on the front until they're into place, and you get some spare neoprene replacement if it gets worn. It's only if you sort of leave it kicking around, otherwise it should last a very long time. So the vacuum system works by extracting the air from this void. It doesn't matter how deep the void is, it's just going to extract the air from there. And then it works on the sort of surface pressure, if you like. So the bigger surface area you have, the more pressure or strength you have. Both of those will still go up to -25, -26, but the fact that the smaller one has a lower surface area, it's going to have a slightly lower grip than what the larger chuck. So just bear that in mind when you're using the system. So we recommend a max RPM of 1000 for safety. If you go too fast, then there's a possibility centrifugal force may make something happen, but just as a general rule, 1000 sort of RPM is what we suggest. The actual bearings and the seals inside are actually rated for 17,000 RPM. So it's not because you're going to burn anything out, it's just purely, it's a nice safety level of 1000 RPM. So why would we normally use a vacuum system? You could make cheeseboards for a living, and you don't want to see any sort of fixing, so you just vacuum the board on there, turn one side, undo the vacuum, turn it around and do the other side. But typically you would use a vacuum system for ease of turning and finishing the bottom of bowls off. I use mine also for spheres. I use it if I'm making owls, and I use it to hold spheres to router the parts for the decoration. So there are other applications just than sort of turning the bottom of feet off. But I'm going to fire it up and just turn that for demonstration so you can kind of see how it works in operation. So when you turn a bowl, this has got a spigot on there. I always sort of like to put the centre in because that helps you sort of centralise it up. So if you want to turn that off, you typically use your drive just to sort of centralise that up onto the vacuum chuck before switching it on and taking that away for use. So last minute checks, we've centralised it up. Always check that you're above -20. I sort of use that figure as a sort of safety zone, if you like. Anything below that, it starts to get, less of a grip. So -20 and above, I normally say is a safe zone. And as you're turning, just keep looking at your dial to make sure that it just doesn't suddenly drop. If it starts to suddenly drop, then you could have a crack in the wood, or you're getting very thin, and you need to address it. So just keep an eye on your dial as you're turning the bottom of the foot off, which we're just going to do now. Okay, so let's finish the bottom of the bowl off. You notice that I'm just doing small cuts. You don't want to take really big, heavy cuts. Just small cuts, you'll soon get there, and then we can do like a finishing cut. Slightly undercutting. And then we can get that sanded up, and the bowl will be finished. So if you're turning really thin bowls and you want to turn the bottom of the foot off, you've got to be careful, because if you use full power of the vacuum system, if it's very thin here, you could actually implode and actually break the wood. I've done that before. So if you are turning something thin, just bear that in mind and adjust the pressure. So just adjust the pressure to sort of -20 rather than sort of -28 or whatever the maximum is. And then you're less likely chance to damage or distort your bowl if it's really thin. So the other good point just to mention is that some thinner bowls, the wood is actually very porous. So there's no cracks, there's no holes, and you're thinking, why aren't I getting a good vacuum? It might only go to like -15 or something. Quite often porous woods will actually suck the air through, and you could actually feel it sort of on the outside surface. So in those what's the word? So if you come across this, what you need to do is just use some ordinary sanding sealer and just coat that on the inside of your wood. Let that dry for 10 minutes, and then you'll find that that will stop the air pulling through the timber, and you can carry on using the vacuum system. So please feel free to get in touch if you have any further questions about the vacuum system. It's a really comprehensive system that we've made. It's about half the price of a sort of competitor's piece of equipment, similar sort of standard of this, and I think you'll find a very useful tool to your turning equipment. So thanks for watching, and check out some of the videos where I've actually got the system in use. Thanks for watching.